Hi, welcome to the Azure Data Explorer webinar. My name is Uri Barash and I lead the product management team for Azure Data Explorer. We are kicking off a series of monthly webinars, and the first one, this instance, is going to cover an overview of the service. In parallel, we have the team ready to interact, answer questions, and meet you in the Ask Me Anything link that's posted in the chat. We hope you find this time extremely valuable. Let's dive in. Azure Data Explorer is a big data interactive analytics data platform that's optimized for telemetry workloads like logs, time series, and other streams of activity records. When we are processing the stream of events, we observe the Lambda architecture where we have three different paths for processing data. In the hot path, we are evaluating predefined standing queries against the stream of events coming in, applying that logic to generate alerts, to take actions, and respond immediately in very low latency in general. Then we find technologies like in-memory processing, stream analytics, and so forth. On the other side, we have the cold path where we stream those events into relatively low-cost storage, and we are able to run batch processing on this data. It can be huge data, unlimited in size. We can run any code that we want, so it's unlimited in power, but it also takes quite a lot of time. Here we find technologies like Hadoop and other batch processing capabilities. In the middle, we have the warm path. In the warm path, consider it as a glass window into the pipe of information that's flowing in, covering data from seconds old all the way to days, weeks, months, and sometimes even years old. And here we find technologies like column stores and indexing that allows us to apply ad hoc queries and analyze things interactively on fairly fresh data. Azure Data Explorer is a warm path processing technology. And what we've observed at Microsoft is that once teams started using Azure Data Explorer, they tend to move workloads from hot path to Azure Data Explorer because they can run more complex algorithms, take more context into account when responding to events as they come in, generating less false positives and more accurate results, trading off a little bit of latency so it detects things after like seconds and not milliseconds, but provides a lot more accuracy. We've seen teams like the Xbox team that moved 95% of its cold path processing from our internal MapReduce system to Azure Data Explorer, trading off the amount of data that's being processed in each query, in each job, but on the other hand, reducing dramatically the latency of running a query. So instead of running a query for 30 minutes, you run it for 3 minutes or less, trading off the amount of volume towards like immediacy and interactivity of the query that allows you to create an hypothesis, test it, change it, test it again, and be much more productive during the day. When we look at the data that modern businesses are processing, we can see the red data here, and that's data that's been in computer systems since the 70s of the previous century. But we've observed a dramatic growth, both in data volume and in data complexity, and also in data velocity. More data is arriving faster. And we've seen that with Web 2.0, where a lot of text data came in, digital marketing, search marketing, etc., advertising, and more is coming. And the big data wave is really flooding us with a variety of different types of big data. And moreover, the business environment is becoming more and more agile. It's changing. new types of devices, new types of applications, new versions of application devices, changing vendors, changing business environments, they all contribute to a change in the expressiveness and the type of data that we collect. Therefore, data pipelines cannot change on a daily basis to accommodate that. And this is why a lot of folks are encoding data in free text fields and JSON records. In the past, we used to aggregate data as it comes in order to reduce processing cost. However, today, because we don't know what kind of aggregate we'll need tomorrow, we often just collect the data as is into the cold path, into the warm path, and avoid aggregating it on demand, losing data, because new decisions and new queries arrive on a daily basis. We need to be able to answer questions that we didn't know we'll need to answer yesterday. Therefore, creating a curated model upfront and hope that it will survive for a year, 3 years, 5 years is no longer an option. Moreover, more and more queries that come in on a daily basis, business questions like that, require more and more decision makers that will be able to be empowered with data to make data-driven decisions on real business things. And the interesting domains that led this are especially the domains where we have an adversary, whether it's in the security domain that led this revolution with hackers that provided new challenges on a daily basis, and the business environment where we have competition, all the way to the operational environment when we have malfunctions and breakage happening in unpredictable manner and times. This is exactly what we refer to as the digital transformation, the necessity for each organization and system to sense everything that's happening around it, what it does with its customers, with its vendors, with its partners, with the marketplace that it participates in. All these elements of information needs to be taken into account when we optimize how our system works. These questions can take a lot of forms. For example, why are my shoppers abandoning their shopping carts? Why is this device breaking down? What is impacting quality? Those are questions that often needs to be answered even within the day and sometimes even faster than that. This is why we built Azure Data Explorer, which is a fully managed data analytics service optimized for data streaming in and designed for data exploration. In one sentence, it's a big data analytics cloud platform for interactive ad hoc queries. It's a big data, append-only stream of records, because we are ingesting activity in the most common case. Optimized for big data. The 3 V's of big data are high volume, high velocity, and high variance. And when I talk about velocity, I'm talking about a service that can ingest 200 megabytes per second for each node that's deployed in the back end of the system. And because it's an append-only data platform, we can scale out as needed. So in one sentence, Azure Data Explorer is an append-only data platform for big data. And the 3 V's of big data, high volume, high velocity, high variance, when we're talking about high velocity, we're talking about ingesting 200 megabytes per node per second that's deployed in the backend of the system. And because it's an append-only data platform, we can scale out horizontally as needed. We expose the typical data model with tables and rows and columns, so you can filter or aggregate joins, calculate columns, and also run full text search, text analysis, time series analysis, and even run Python and R code embedded in the query language very close to the data. It's fully managed on Azure, and it comes without any specific domain knowledge attached to it. We have solutions that are built on top of Azure Data Explorer that apply knowledge in security, in operations, in other domains. But this comes vanilla as a general purpose data platform that's purposely built for this type of data, high velocity data that needs to be ingested really quickly and analyzed. And it's optimized for interactivity. Let me show you what I mean by interactivity. Here we're looking at the GitHub activity records repository that has a record for each interaction of a user with the GitHub service. In this table, we have 1.2 billion records that spans sometimes between January 2016 to February 2019, 3 years of operations. And if we want to see if the data is complete, how it behaves, let's aggregate the data on a daily basis and see how it behaves over that period. And what we can see here is that the data is pretty complete, it's consistent, and we can identify very easily the holiday seasons for those 3 years. And we can even see weekends. When we dive into the data itself, we can see that some of the data is structured, like the ID and the type and the date, but a lot of it is actually pretty complex. Each row can have its own schema. If we look into the actor field, you can detect the display login. This is actually the unique identifier for the user that interacts with GitHub. With Azure Data Explorer, we can query into JSON fields. For example, in this case, I'm generating a calculated column from the display login element of the activity record. I can do more interesting stuff, for example. Let's see how many unique users interacted with GitHub during that period. For that, we'll run a distinct count over the internal actor display login field. That is practically cranking up 1.2 billion JSON records, and the result is 16 millions, and it came back in 5 seconds. Let's take a look at additional example. In this data set, we have 30 terabytes of data. On disk, we keep everything compressed, so on disk it takes about 3 terabytes of data only. And the data is organized in 2 main tables. One is the trace table that has 22 terabytes of data, and the other one is a performance counter table. This is a log table, a broader table with multiple columns and diverse content, and the performance counters is really measurements, time series, or metrics. We'll start with the log table. The trace table will take the trace table, we'll pipe it into the count operator that takes a 41 billion row table and 15 columns and transform it into a 1 column, 1 row table with a number 41 billion in it. But let's do something that's a little bit more complex than counting rows. Let's take those 41 billion rows, slice only 1 day out of them, so we only get 800 million records, and then aggregate those 800 million records by the error level. And we can see here that we have 2.5 million errors in this data set. By the way, this query ran for 790 milliseconds. By the way, all the queries that I'm running here are completely calculated from scratch every time I run them. Nothing is cached. So before we drill down and see what is the reason for those 2.5 million errors in this data set, let's take a look at the data. In this data, we can see we have date and time, low cardinality strings, high cardinality strings, integer, doubles, and whatever you can expect from a database, all the way to full text fields. All of them, including arrays and JSON columns, get indexed automatically without the need of any tokenizers or any other elements as the data comes in. When we're looking at the role field, we can see that the role field is practically an aggregate of two different data points. One is the machine that's generating the traces, and the number is the index of the machine in the array. It doesn't help us to understand if there is one type of machines in this array that's generating more errors than the others. So what we'll do, we'll pass the role field into the role type element, throwing away everything after the underscore, and then we'll aggregate this by the role type in bins of 10 minutes and see how it behaves over time. As you can see, there is one type of machine, the SPI role machine, that's generating more errors than the others in this data set. By the way, this query runs for 400 milliseconds. This is the type of performance that column stores and deliver. But let's take a look at a query that other products have harder time with. Let's find the user that has suffered the most during that day by searching for login events, extracting the stable ID from the event text as we've seen earlier, associating the session ID with the stable ID, joining it back into the alerts table, and then aggregating by users to see which users got the most errors in this data set. And we can see that 3309 is the poor soul that suffered almost 2,000 different errors. We can now dive into what 3309 experienced and see by extracting the actual error code from the event text, we can see that in this case, both the database was not found, and there was some problem with the network for this specific account. And because the cardinality is pretty much the same, we can assume that this is the reason and that those two errors are connected. So we've seen how we can aggregate data really quickly on dimensions, which is a classical dashboard element. How we can investigate and get to the root cause, and we can even dive into a specific session and see what's happening before, during, and after the error. And we can also run alerts on the same data set. And this is what's unique in systems that build on Azure Data Explorer. The phenomena that you investigate from the dashboard and the phenomena that you investigate because you got an alert, they all rely on the same data. So when you investigate something, the same data that generated the alert is there in the system to help you understand the answers. No gaps between those different systems. In the data domain, quite a lot of people are using the SQL query language. This is why we made it possible and easy to convert SQL statement into KQL, the language that is being used here, but also in Azure Monitor or Log Analytics and a bunch of other security products from Microsoft. Not only we can convert queries, but we actually can run SQL queries natively in Azure Data Explorer. So this is a T-SQL query that just executed as is. Practically, Azure Data Explorer also supports the TDS endpoint. So for all practical reasons, it can serve as a read-only SQL server, and we'll talk about it more in the architecture section. Let's switch gears and talk a little bit about time series. Now we're looking at the performance counters table. As I mentioned, it's 6.5 terabytes of data, hosts 30,000 different time series with 35 billion measurements in this table. And now we're looking for the 3 machines that reach the highest CPU in this data set. And we'll try to see why those machines reach 100% CPU, or at least were the highest ones in the array. And when we're looking at the machines here, we can see that this machine had peaked here. We investigated and it rebooted, but the other 2 machines are kind of leaking CPU. And it's interesting for us to see if there are more machines in this data set that exhibit similar behavior. So we'll leverage some ML building blocks that are embedded in the Azure Data Explorer system. And in this case, we'll look for shapes. We'll look for jump shapes in the CPU consumption graphs. And you can see that the phenomena is actually broader than the other 2 machines that we've seen earlier. You can even see exactly where the phenomena started, and this is probably where we deployed the software that created this bug of leaking CPU across the workload. There are some more elements of machine learning already embedded, and this is, I'm talking here about unsupervised, but there's also the ability to run Python and more ML capabilities. We'll expand on this later. But in this case, we want to ask a very simple question. Remember the 2.5 million errors that we've seen earlier? Let's take a look at the dataset and see how can we cluster those errors and see what are the main reasons for it happening. Now, this auto clustering tries to identify what's common to many of the rows here. And you can see that 42% of the errors are generated by the SPI role, especially the SPI role machine number 4 that's generating a lot of errors. This actually pinpoints very easily what is the problem and how to go and fix it. Let's switch back to the slides. Azure Data Explorer has been in production for 6 years now. Started when 4 engineers from the Power BI team needed a way to store telemetry for the service being ported to the cloud. They created the log repository for logs and telemetry in general, and it was quickly adopted by the entire Microsoft, with Office and Windows replacing Splunk to use it, saving about 70% of the hardware cost, replacing Elasticsearch and Sumo Logic and New Relic across the board at Microsoft. Even the data platform today, Azure SQL, Cosmos DB, Data Warehouse, Azure Storage, are all using Azure Data Explorer to store and analyze their telemetry. Very soon after, it was adopted as the platform of choice for analytical solutions as a service in products like Azure Monitor, Application Insight, Log Analytics, the security product, Azure Security Center, Sentinel, Microsoft ATP, the IoT stack, gaming analytics, and very recently also in the customer insights from Dynamics. 2019, we released it as a generally available service on Azure, so our partners and customers could actually leverage the best practices that we've developed in order to deal with telemetry data. Just to give you a little glimpse, Azure Data Explorer runs on every region in Azure. It has over 2 exabytes of data under management, growing, almost doubling during the last year. We ingest over 36 petabytes of data on a daily basis and running on more than 1.1 million VM cores in Azure. Another interesting number here is the 35,000 unique users only within Microsoft. This is the number that signifies the digital transformation that we powered at Microsoft, with nearly a fifth of the workforce actually running queries in their bare hands, just like I showed earlier, against data, empowering people with data. So let's take a look at how Azure Data Explorer operates. Azure Data Explorer can ingest data from the data lake. It can also listen to data landing in the data lake via event grid notifications. It can ingest data from event hubs, IoT hubs natively, and it can also connect to Kafka deployments via the Kafka connector, gold certified Kafka connector, and using the Logstash plugin to listen to Logstash pipelines. You can also naturally connect via the REST API and client libraries in all common languages. Azure Data Factory allows moving data around in Azure, and it's a powerful platform that can help move data into Azure Data Explorer. And last, the Spark connector allows taking the outputs of Spark jobs and also Spark streaming and pushing that data into Azure Data Explorer. When data arrives at Azure Data Explorer, it gets indexed, compressed, organized as a column store, and stored in the local SSD of the machine ingesting the data and the underlying blob storage for persistency. In cases where data comes in a trickling manner, every row at a time, the data first, before it gets organized as a column store, it gets organized as row store that allows even trickling data to be queryable within seconds. When the row store fills up, it gets converted into a column store, and then it's stored alongside all the other elements of the data that were ingested using queued ingestion. When someone is trying to query the data, they can do it via the REST APIs, but also via the TDS endpoint, and also ODBC, JDBC, etc., client libraries in all common languages, etc. Also via Power BI, both in get data and direct query modes. The ADX UI, Azure Data Explorer UI that I demonstrated earlier, including dashboards that I'll show in a second, is another great option. You can query data via Power Automate, Flow, Logic Apps, Azure Data Factory, and other orchestration tools. You can use the Jupyter notebooks, including the KQL Magic that allows writing queries directly in notebooks and getting data frames back. You can leverage open source dashboards like Redash.io, Grafana that has native connectors to Azure Data Explorer. And you can also use Spark and the Spark connector to query data, pushing predicates down, running Spark jobs only on the relevant data for the specific job, and then avoiding keeping the data in multiple locations. One interesting scenario with the Spark connector is that you can run a Spark job on the data in Azure Data Explorer, train a model, and then upload the model back into Azure Data Explorer and use it in order to run the model on data that's coming into Azure Data Explorer using a feature called update policy that allows kind of like a trigger to process the data as it comes in and store the results in another table. Azure Data Explorer can also query on-demand data in the data lake, data in SQL servers, in Cosmos DB servers, and soon in HTTP servers, general HTTP servers as well. As I mentioned, the data is stored both in the local SSD and in Azure storage for long-term persistency. When the data age passes the caching policy, the data gets evacuated from the local SSD and remains only in Azure storage. And then that's where we call it cold data. When a query comes in and referring data that's available only in the ingested area, ingested data in Azure storage, it gets fetched back into the local SSD, and then a query is being evaluated and returned. From the user perspective, this is completely transparent, only a bit slower. When the data ages further and reaches the retention policy definition, it gets deleted from the ingested data and does not exist anymore. Azure Data Explorer can also export data to the data lake. It can do a one-time export, but it can also do a continuous export. For example, for scenarios where data is arriving in via Event Hub in a trickling manner, Azure Data Explorer can actually export data into the data lake, arranging it in the data lake formation in Parquet or in other formats for other tools and engines to consume. So to summarize, the ability to combine metrics and time series data and analytics, text search and text analytics, wrap it all up together with multidimensional relational analytics via a simple and powerful query language, the ability to combine Python and R and inline in the query language, very close to the data, and the support for T-SQL provide a comprehensive set of analytical capabilities. The service scales out by adding nodes as needed. It also supports autoscale, so you can configure it to adjust to inflate and deflate as needed by the workloads automatically. You can also choose which type of hardware do you run to best target the workload parameters to the hardware configuration underneath. The ability to ingest high velocity streams, control automatically the retention and caching of the data in the different layers based on database, based on cluster, and based even on table granularity, provides a lot of control over cost and performance. Let me show you how cost is calculated. This cost calculator or estimator is currently being integrated into Azure Cost Calculator, and it provides you the ability to predict how much an Azure Data Explorer deployment would cost. For example, if we take a deployment that will generate 1 terabyte of data per day, we'll store it for 14 days in the hot cache on the SSD of the machines, and for 30 days in total retention. The cost for that would be $3,000 on a pay-as-you-go and $2,000 per month using reserved instances. The way we are calculating the cost, we are actually passing through the cost for the hardware, machines, premium storage if we are using it, storage, network, etc., and a service cost to reach this sum. In big data, this is the Azure Data Explorer cost calculator or cost estimator. We are in the progress of integrating this into the Azure Cost Calculator, the formal Azure Cost Calculator, but it provides you the ability. It's available from the Azure Data Explorer pricing page, and it allows you to predict how much your Azure Data Explorer deployment would cost. For example, if we're taking a deployment with 1 terabyte of data per day, storing it for 14 days in hot cache, providing 2 weeks of data for fast queries, and 30 days of total retention of the data for point queries, And you can see that that's such a deployment, which is a pretty massive big data deployment, can cost as little as $3,000 with pay-as-you-go and $2,000 leveraging reserved instances. The way that we cost the service is we pass through all the hardware costs and we take an additional service fee for the service and software operation. The minimal deployment that we can actually run would be about like $300 a month with reserve instances, but it still allows a pretty powerful data storage and query. For the purpose of like developing software and solutions built on Azure Data Explorer, we also exposed a dev test SKU that runs on a single box, and you can have it running for almost like $50 a month using reserved instances and develop everything that's needed against the Azure Data Explorer. So key usage patterns. People use Azure Data Explorer to empower people of all disciplines to generate insight based on data and understand the activity of the business, and way beyond IT operation, but also into business operations, inventory, and practically every activity that surrounds the business. People use it to build product features, analytical product features based on the data, operational data that's collected in Azure Data Explorer, and near real-time monitoring experience, including alerting, data exploration, dashboarding, etc. One common question is when to use Azure Data Explorer and when to use the different vertical solutions that are built on top of it. Azure Monitor for operational management of IT assets, Azure Security Center, Azure Sentinel, ATP, and the other security products from Microsoft. The IoT stack, gaming analytics, connected vehicles, etc., etc., etc. And the answer is, we definitely recommend to use the vertical solutions as they will continue to evolve, deliver more value in their specific domains, and allow you to focus more on your business. In cases where those solutions do not fill your need for the specific workload, and you decide to build a solution, then Azure Data Explorer as a platform as a service PaaS can be the best platform for you to build this, providing also interoperability between those vertical solutions and the data, the custom application that you are building with Azure Data Explorer. Here is a set of reference architecture that we've published online, how we're doing big data analytics, how we're doing end-to-end monitoring together with Azure Monitor and Sentinel, how to set up a data exploration environment, IoT telemetry, and media and CDN analytics environment, which is also a fairly common scenario. This is just a small set of customers that have published references and case studies on our website. And in general, we're seeing a lot of customer love across probably every segment in two main scenarios. One, creating a data lake, a log lake for every activity that happens in the organization, and the ability to build an analytical solution as a service application in a variety of domains. We highlight three typical customer patterns in cloud scale analytics: data warehousing, real-time analytics, and machine learning. Azure Data Explorer participates heavily in real-time analytics and also in machine learning. Over the last year, we've released Azure Synapse Analytics as a way to collect all the relevant components for modern data warehousing and deliver an end-to-end experience that implements it. A month and a half ago, in the Azure Data Explorer virtual event, Ron Kumar, Corporate Vice President for Azure Data, announced that Azure Data Explorer is going to be a native offering as part of Azure Synapse Analytics, covering and extending the pattern coverage to include also real-time analytics. Let's talk a little bit about the characteristics of these patterns. In modern data warehousing, we define a well-curated data model with entities and attributes that are well documented. We create an ETL pipeline that takes raw data and converts them into that model. We load that model into a warehouse and we visualize it with analysis services and Power BI. Data warehousing provides a highly consistent, reliable way to provide all application and users of the well-curated data model with consistent semantics across the enterprise. With real-time analytics, we are actually trying to achieve something quite different. We are interested in providing near real-time access to activity, to insights, shorten the time from an event happening and the insight that can be derived from it, and provides different ways to look at the data based on the current challenges of the day. Less about consistency and more about providing agility, applying schema on read to the data to generate the relevant, timely insights. Data is ingested from a variety of sources in real time and is available for querying in minutes or seconds. Azure Data Explorer takes advantage of reservations. Based on its pricing model, we are passing through the cost for the underlying infrastructure, compute, premium storage, and also enable purchasing reservations for the Azure Data Explorer service meters. That makes it possible for customers to leverage their reservation purchases across Azure and across their other workloads in Azure to reduce the cost and increase the flexibility on how they use those reservations in Azure. Reservation for 3 years actually simulates the same type of investment that we are making when we are purchasing hardware for on-premise deployments, and the savings are actually pretty similar. Another important element with Azure Data Explorer is that together with the Azure Data Share service, we are enabling sharing data in place, both with the company, allowing the same data to be shared between several clusters of Azure Data Explorer, allowing separate chargebacks and reinforcing of resources for different workloads. But we are also enabling sharing data with partners and even with customers. In-place data sharing allows Azure Data Explorer users to share the actual data and implementation with partners and customers without the necessity to become an operator for expensive, hard to maintain APIs in order to provide access to data. With that, I'd like to thank you so much for spending the time with us today. We have the team waiting at the Ask Microsoft Anything website to interact with you, answer questions, and connect. This is the first of a series of monthly webinars, and I'm very hopeful to see you in the next one as well. Thank you so much. And here is a set of links and resources for you to be able to learn more and connect with us after the session ends. Have fun using Cousteau. Hi, welcome to the Azure Data Explorer webinar. My name is Uri Barash and I lead the product management team for Azure Data Explorer. We are kicking off